student, I am H.G.TIWARY of DMCCL Greedy. I am going to teach you first chapter, that is relation and function. First of all, I will give concept of relation. Then after, I will come to the function. Student, you know, in general life, a relation between two person like sister and brother, father and son. Likewise, that in set, we also establish relation between elements of two non-negative sets. So first of all, students, you should have concept of Cartesian product of two sets. Let A and B are two non-empty sets. Then A cross B is called their Cartesian product. As for example, if A has element 1, 2, 3 and B set has elements AB, so we can find A cross B. A cross B is equal to, first we take element of A, 1A, 1B, 2A, 2B, 3A, 3B. These are the elements of A cross B. These are ordered pair elements, students. These are ordered pair element. 1A is called ordered pair element. So A cross B is a set of ordered pair elements. So relation, if you want to establish relation, then any subset of A cross B is called relation from set A to set B. Any subset of A cross B is called relation. Any subset of A cross B is called relation from set A to set B. Any subset. As for example, I am taking R, that is, it contains 1A, 2A and 3B. This R. Here, elements of R is elements of A cross B. So R is contained in A cross B. So R is a subset of A cross B. R is a subset of A cross B. So R is a relation from set A to set B. So there are many relations we can establish. Any subset, if you take R1 as 1B and 3B, so R1 is also a subset of A cross B. So R1 is a relation. R1 is a relation. So this is the concept of relation. Now, if R is a relation, then what is its domain and range and codomain of relation? So, to find domain and range of relation, student, if R is a relation, it contains 1A, 2A and 3B. So, domain of R, in brief, domain R, we will take a student set made by first element of order pair 1, 2, 3. This is the domain of R, and range of R, range R. We take other element A and B. Here A is repeated. We write only one time A and B. This is the range of R relation. This is the domain of relation. This is the range of the relation, and codomain of R will be set B. A say B, so set B. That is, we have AB is codomain. So in this way, we can find domain, range, and codomain of relation. Now, student, if 1A belongs to R, it means 1 is related to A. 1 is related to A. 2A belongs to R, so 2 is related to A. Here 3A does not belongs to R, so 3 is not related to A. So these are the symbol of which one related to this. If this is element of R, this ordered pair, so 1 is related to A and 2A is related to A, 3A is not there, so 3 is not related to A, so 3 is not related to A. So these are the concept of regarding domain and range and codomain of a function. So this is the codomain of relation, student. So this is the relation by which any subset of A cross B is a relation. So student, if we take here A cross A B is also subset of A cross B, student. A cross B is a subset of A cross B. So this A cross B is called universal relation. Universal relation. It is called universal relation of A cross B. Null set is a subset of A cross B. So it is called void relation. So different kinds of relation, students, we will study here. If A is a set having elements 1, 2, 3, so find A cross A, that is 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So it is A cross A. It is relation on A. A cross A. This is the relation. Relation on non-empty set A. So this is called binary relation. It is called binary relation. So any subset of A cross A is also a relation. So also we define relation if R is a relation on set A, then R is said to be reflexive relation if for all A belongs to A is related to A. For all A belongs to A related to A. That is if A has 1, 2, so if R is reflexive, then R should be 1, 1, 2, 2. This is must. After this 1, 2, but this 1, 1 and 2, 2, it must contain 1, 1 and 2, 2. So it is a reflexive relation or a reflexive relation on set A. Then we take symmetric relation. Symmetric relation. If A is related to B, implies B is related to A for all AB belongs to A, then R is said to be symmetric relation. Symmetric relation. So R is reflexive. If this condition is satisfied, if A is related to B, then it must be related to A. Then R is said to be symmetric relation. Then we come to transitive relation. Transitive relation. If A is related to B and B is related to C, implies A is related to C for all ABC belongs to R, then R is said to be transitive relation on set A. So this is the concept of reflexive relation, symmetric relation and transitive relation. If R on set A is reflexive, symmetric and transitive, then it is called equivalence relation on set A. If R on set A is reflexive, symmetric and transitive, then R is said to be equivalence relation on set A. So for equivalence relation, it should be reflexive, symmetric and transitive. All the three relations are satisfied for R on set A, then R is said to be equivalence relation on set A. So questions will be asked to prove that this given relation is equivalence on a given set. You have to show first it is reflexive, then symmetric and transitive. These are the relations. One also relation is identity relation, concept of identity relation. identity relation on set A if A has elements 1, 2, 3, then identity relation on set A denoted as IA and it will contain 1, 1, 2, 2 and 3, 3. Only these elements, these ordered pair it will contain, it is identity relation. This is the identity relation. What is the difference between identity relation and reflexive relation? So, in reflexive relation, in reflexive relation, if R has 1, 1, 2, 2, 3, 3, it will also contain, other than this, it may contain 1, 2. But for identity relation, it only contains 1, 1, 2, 2 and 3, 3. This is identity and this is reflexive. It contains 1, 1, 2, 2, 3, 3. Apart from this, also it contains 1, 2. So this is a reflexive relation. This is identity relation. This is difference between identity relation and reflexive relation. Student, this is the concept of relation and how to find domain, range, codomain of relation, kinds of relation. I have given concept to you. Thank you.